A cubic polynomial gives reminders 5x minus 7 and 12x minus 1 when divided by x squared minus x plus 2 and x squared plus x minus 1 respectively. Find the polynomial. Now from the question, we know that what we are supposed to find is a cubic polynomial, which of course we know that a cubic polynomial is a polynomial whose highest power of x is 3. And since we know this, then we can safely say that the polynomial is of the form ax cubed plus bx squared plus cx plus d, where a, b, c and d are real numbers. Now from the question, we are told that the polynomial, let's call it p of x, is divided by x squared minus x plus 2, and we get a remainder of 5x minus 7. That's when the polynomial is divided by x squared minus x plus 2, we get a remainder of 5x minus 7. Now before we analyze this step, there is one thing we should be aware of, which is if we have two polynomials, let's say f of x and g of x, where f of x is the polynomial with the higher degree. Now if g of x were to divide f of x, then the remainder must be a polynomial whose degree is less than that of the divisor, which in this case is g of x. It should be less than the divisor by 1. And what does this tell us? It tells us that since we have a cubic polynomial that's to be divided by a quadratic, then the remainder should be 1 degree less than the quadratic. That the remainder should be a linear expression, which according to our equation makes sense. Now let's go ahead and divide using long division. Now this is how you set it up: ax cubed plus bx squared plus cx plus d to be divided by x squared minus x plus 2. And now to make ax cubed, we multiply the divisor by ax, which gives ax cubed minus ax squared plus 2ax. Yeah, and now we subtract, and that gives us b plus ax squared, because ax cubed minus ax cubed will be 0, so we will not write that. So for the second thing, we have b plus ax squared. The x squared will be multiplying everything in the bracket. Now plus c minus 2a x will be multiplying everything in the bracket too. Now plus d, because d minus 0 is 0. Yeah, to make b plus a, what we are going to do now is to multiply the divisor by b plus a. Now if we do that, we get b plus ax squared minus b plus ax plus 2b plus a, and if we subtract, we'll get c minus 2a plus b plus a x plus d minus 2, you open bracket, b plus a. Now this x is multiplying everything inside the bracket, and you can also see that our remainder is a linear expression because the highest power of x is 1. Now remember that from the question, we were told that when the cubic polynomial is divided by the quadratic, the remainder is supposed to give us 5x minus 7, which means that the remainder we got is the same as 5x minus 7. Now as you can see with a glance that we can compare coefficients, and doing just that, we get that for the coefficient of x, we have that it is c minus a plus b is equal to 5, and we're going to call this equation 1. And for the constant term, we get that d minus 2b minus 2a is equal to minus 7. and we are going to call it equation 2. At this stage, there's not much we can do except to go back to the question and search for more hints. And as you can see, that just like the one we just finished now, the cubic polynomial is to be divided by another quadratic to give another remainder. So we'll do just that. Also, the process would be similar to what we did previously, so I'll just go ahead and solve straight. In the end, as you can see, we arrived at another pair of equations, which I'll call equation 3 and 4. Let me write down all the equations so we just see them at a glance. So now we have 4 equations with a total of 4 different variables, but it would be best if we can eliminate 2 variables so we can then solve a simultaneous equation with 2 variables. So now, looking at equation 1 and 3, they both have the c variable in them, so we can subtract equation 1 from equation 3, and that would give 3a minus 2b is equal to 7, and we call this equation 1a. Now, since this equation has only the variables a and b, then whatever equation we are going to get next must also only have the a and b variables, and in that case only equation 2 and 4 fit that criteria, because we can just subtract equation 2 from equation 4 to eliminate the d variable and get a plus 3b is equal to 6, and we call this equation 2a. And in equation 2a, we can make that in this same equation we can make a subject of formula to give a is equal to 6 minus 3b, and we call it equation 2ai. And we can still substitute it in equation 1a to give 3 open bracket 6 minus 3b minus 2b is equal to 7. Now we can expand the brackets to get 18 minus 9b minus 2b is equal to 7, which simplifies to 18 minus 11b is equal to 7, and subtracting 18 from both sides give minus 11b is equal to minus 11, and we can divide out to give b is equal to 1. That's, we've gotten the answer for b. Now putting b as 1, that's substituting the value for b in equation 2ai, we get that a is equal to 3, and from equation 3 we can make c subject of formula, plug in the values of a and b we got, and then solve to get that c is equal to 7. Similarly, we can make the subject of formula in equation 2, plug in the values of a and b we got, and then solve to also get that d is equal to 1. Now, collecting our results together, we have that a is equal to 3, b is equal to 1, c is equal to 7, and d is equal to 1. And to get our final answer, all we need to do is to substitute these values we got into our assumed polynomial expression, and we get that the polynomial is 3x cubed plus x squared plus 7x plus 1, and that's our answer, which brings us to the end of the video. Please subscribe to my channel and turn on notifications so you'll not miss any of my future interesting math videos, and also like the video so it gets recommended to others who might find it helpful. Have a great day. Peace.